Welcome to today's course in Anatomy and Physiology. Today we'll be talking about water balance homeostasis. First, let's recap. What is homeostasis? It is the maintenance of the stable internal environment of the body even when there are changes in external environment. I will be focusing on water balance homeostasis in the body. The body maintains a balance of water intake and output by a series of negative feedback loops involving endocrine system and the autonomic nervous system. Water intake is through food and drink and cell metabolism, and water output is mainly through kidneys, lungs, and GI tract. As you can see, maintaining water homeostasis is a balancing act. The amount of water taken in must equal to the amount of water lost. Water balance homeostasis is all about plasma osmolality. It is a ratio of solutes to water in blood plasma. A person's plasma osmolality value reflects his or her state of hydration. A healthy body maintains plasma osmolality within a narrow range by employing several mechanisms that regulate both water intake and outputs. Let's look at a cross-country runner to see how fluid balance is maintained. Notice as the runner is sweating. If he continues to lose water and to a lesser extent salts, he may become dehydrated. When the runner loses water by sweating, his plasma becomes more concentrated in solutes, and osmoreceptors in the hypothalamus detect the increased osmolarity or concentration of solutes in the plasma. And in response to this increased concentration, antidiuretic hormone is released into the blood at the posterior pituitary. The target tissue of ADH are all in the kidneys. The nephrons in the kidney become permeable to water only in the presence of ADH. ADH also promotes the addition of water channels into the cells of the late distal convoluted tubule and collecting duct, allowing water to move from the filtrate to the plasma by ways of osmosis. ADH therefore increases the reabsorption of water. Water intake is also regulated by the thirst mechanism. The thirst mechanism is a primary regulator of water intake and involves hormonal and neural input as well as voluntary behaviors. There are three major reasons why dehydration leads to thirst. First is when saliva production decreases, the mouth and throat become dry. And second is when you're dehydrated, blood osmotic pressure increase. And then third, the decreased blood volume causes a decrease in blood pressure that stimulates the release of renin from the kidney, and these will all stimulate the third center in hypothalamus. And the stimulation of the third center in the hypothalamus gives you the desire to drink. Then there is fluid ingestion. After that, the third center will stop sending signals. The kidneys also must make adjustment in the event of ingestion of too much fluid. Diuresis, which is a production of urine in excess of normal levels, begins about 30 minutes after drinking a large quantity of fluid, maintaining the balance of water in the body. Now let's wrap up. So homeostasis requires that water intake and output be balanced, and water balance is maintained within a narrow range by negative feedback loops involving the hormones ADH as well as the thirst mechanism. So that's it for today's course on homeostasis, water balance homeostasis. Thank you for watching.
Created using Powtoon.